So, hello, my colleagues, and we left off the last time looking at this cutting dividends for profitable growth. And now let's look here at this example, unprofitable growth. Okay. Suppose Crane Sporting Goods decides to cut its dividend payout ratio to 75% to invest in new stores, as an example 9.3. But now suppose that the return on these investments is 8% rather than 12%. Given its expected earnings per share of $6 and its equity cost of capital of 10%, what will happen to Crane's current share price in this case? So if you go through this solution, the dividend's going to fall to $4.50, right? They're only paying out 75% of the $6 that they of their expected earnings. So its growth rate under the new policy is going to give this lower return on new investment, which will now be 25% of 8% is 2%, right? Because the 8% it's going to have a return on new investments of 8%, and 25% you're going to keep, right? So the new share price now is going to be 450, right, which is the dividend here, over the return on equity, and the growth rate is at 2%, right? If the equity cost of capital is still 10%, right? So the new share price is now 56.25. Thus, even though Crane will grow under the new policy, the new investment have negative net present value, right? You can see there's negative net present value here, because the return is less than the cost of capital, right? So everyone sees that, right? 8% return when its investors can earn 10% on other investments, right? So anyway, so I just wanted to show you that. So let's go through this. They'll show you the same example I just did, so you get it from two sources.
Unprofitable growth. In this problem, we're going to continue our analysis of Crane Sporting Goods' decision to potentially cut its dividend in order to invest in future growth. Again, we'll be using the constant dividend growth model to evaluate the impact of this decision on Crane's stock price, but this time we'll look at the consequences for growth of a more pessimistic assumption on their return on new investment.
Let's begin by reviewing what we did in the prior example. We began with the initial information regarding Crane's stock price. Investors expected a $6 dividend and no growth. Given Crane's $60 share price, this meant investors expected to earn a 10% total return, corresponding to Crane's dividend yield. This expected return represents Crane's cost of capital. Under the new policy, Crane planned to cut its dividend to $4.50, reinvesting the remaining 25% of its earnings to support growth. Given a retention rate of 25% and return on new investments of 12%, this policy implied a 3% expected growth rate of Crane's future earnings. Using the constant dividend growth model, this implied an increase in Crane's share price to $64.29. Now let's see what happens if we reduce the expected return of Crane's new investments. The first step of the analysis is the same. Crane plans to lower its dividend payout rate to 75% and thus reduce its initial dividend to $4.50 in order to retain and reinvest 25% of its earnings each year. Of course, the impact this strategy has on Crane's growth rate will depend on the return it earns on its new investments. According to the formula, we can estimate earnings growth by multiplying the firm's retention rate by its return on new investments. In this case, we replace the 12% return we assumed previously with a more pessimistic assumption of 8%. With an 8% return on new investments, Crane's expected growth rate will be only 2% rather than 3% as in our earlier example. Let's see what this means for Crane's stock price. applying the constant dividend growth formula, we see that under this more pessimistic assumption with only 2% growth, Crane's stock price will fall to $56.25 if it cuts its dividend to reinvest. Why did the stock price fall in this case while it rose in the prior example? You guessed it, in this case Crane's new investments are not positive NPV. They have an expected return of only 8%, which is below Crane's equity cost of capital. Thus, we can see that the impact of cutting the firm's dividend in order to reinvest will critically depend on the quality of those new investments. If investors believe the new investments have positive NPV, the stock price should rise as the increased growth more than makes up for the dividend cut. But if the new investments have negative NPV, then the change in policy will cause the stock price to fall. Note finally, though, that in this last example, while the stock price will initially drop from $60 to almost $56, going forward the stock price will be expected to rise at 2% per year as the firm grows. Thus, the firm's stock price will eventually exceed the original $60 share price under this new plan. But that growth will come too slowly for shareholders to benefit, and they would be better off if the firm did not grow, but instead just continued to pay high and steady dividends into the future. In other words, not all growth is good. Only growth that comes from positive NPV projects will increase the value the firm is creating for its shareholders.
Okay, so that's an important point, and I highlighted a very, very important line with just what he said. Thus, cutting the firm's dividend to increase investment will raise the stock price if and only if the new investments have a positive net present value. And that's always the underlying point here. Okay? That's always the underlying point. All right, so we'll pick up here on changing growth rates next time, okay?